Welcome to this day in his story, created by American Heritage Worldwide, a reminder that every day holds something new to learn. Did you know that Galileo suffered persecution and house arrest for the remainder of his life when he discovered that the Earth orbited around the Sun? Look with us through a telescope at the Moon and gain an understanding of the solar system and how Jupiter's 4 moons challenge the commonly held religious belief that the Earth was the center of the universe.
Okay, let's unpack this. Imagine just one night of staring through a pretty crude telescope. And that one night doesn't just show you something new, it completely shatters centuries of what everyone believed to be true.
It's an incredible moment.
This deep dive is all about that. It's about Galileo Galilei that night on January 7, 1610, and how 4 tiny pinpricks of light just completely redefined our place in the universe.
It really is a monumental moment in history. I mean, you have Galileo, this Italian astronomer, physicist, engineer. He essentially becomes the architect of modern astronomy. And not from some grand theory, but from just watching patiently.
And the sources we're pulling from for this are fantastic. We're synthesizing material that covers his discoveries. We have these really detailed profiles of Jupiter's moons, and crucially, the context on the historical and religious conflict that came right after.
Right. Our mission here is to show you how a better telescope provided real physical evidence for a heliocentric universe.
That the Earth orbits the Sun, not the other way around.
Exactly. And, maybe more importantly, what it cost him personally to state that truth out loud.
It's a celestial revolution, all started by 4 little lights dancing around Jupiter. So let's go there. January 1610, the technology is primitive, the sky is, a mystery, and the belief system is absolute.
It is. So January 7, 1610, Galileo points his telescope at Jupiter. And this isn't just any telescope. He'd improved it himself, so it was way better than anything else available.
And he sees
what he thinks are 3 small, bright stars, just kind of clustered near the planet. Nothing too wild at first.
But the key is he didn't just look once and move on. He kept watching. That observational endurance, it's the whole story right there. He comes back the next night.
And that's when everything changes. He notices that the stars, they've moved, and not just randomly. They've shifted to the other side of Jupiter. So he immediately starts plotting their movements night after night.
Okay, hold on. How did he know they weren't just really distant stars that happened to be in the background? And their position just seemed to change because the Earth moved. How fast did it click that this was a system?
That's the critical question.
Yeah.
And he didn't jump to a conclusion. It was all about the pattern. It wasn't one observation. It was the consistency.
Right.
Within just a few weeks, he finds a 4th object, and he's watching all 4 of them just weave back and forth. They'd cross in front of Jupiter, then disappear behind it. The repeated, predictable motion was the key.
That aha moment must have just been overwhelming.
Staggering. He realized these things were orbiting Jupiter. In the same way our moon orbits the Earth. They were the first moons ever seen orbiting another planet.
Wow.
And this whole thing, this observation, it was only possible because of the technology he'd engineered. And it was the first crack in the wall of the medieval universe.
This is where it gets really interesting for me. Why was seeing 4 dots orbit Jupiter such an explosive, a dangerous idea? It sounds like basic astronomy now, but then it was an intellectual bomb.
It was a bomb. Because for centuries, the established view, the one sanctioned by religious authorities, was geocentrism.
Everything revolves around the Earth.
Everything. The sun, the moon, the planets, the stars. They all revolved around us. Earth was stationary, unique, and the center of everything.
And our sources are clear. This wasn't just a physics model. It was theological. If Earth is at the center, then humanity is literally center stage in God's creation.
Exactly. The whole system required Earth to be the single point around which everything turned. But Galileo's moons, they proved that other centers of rotation existed.
Right. Jupiter had its own thing going on.
If Jupiter could have its own little celestial system, its own moons orbiting it, then the Earth clearly wasn't the one and only center of all cosmic motion.
So that one observation completely pulled the rug out from under the entire geocentric model. Earth went from being the star of the show to just one of the actors.
It was an existential crisis. The physics didn't work anymore. If Jupiter could be moving through space and still hang on to its moons, there was absolutely no reason the Earth couldn't be doing the same thing, moving around the sun. It was hard, observable proof for what Copernicus had only theorized.
Okay, so before we get into the fallout from all this, let's get to know these four moons. Because to be well informed on this, you need to appreciate what he was actually seeing. Let's talk Io, Europa, Ganymede, and Callisto.
Yes, the Galilean moons. And they are four completely different worlds. Each one tells us something unique about how the solar system works.
Let's start with the biggest, Ganymede, the giant of the group.
It is. Ganymede is the largest moon in our entire solar system. The material we have points out it's actually bigger than the planet Mercury.
Wow.
But here's the really unique technical bit. It's the only moon we know of that generates its own magnetic field.
And that's a huge deal, right? A magnetic field implies, what, a molten active core? Something churning inside that's not just a dead rock.
Precisely. It tells us there are complex things happening inside it. It's a world in its own right. Then you move in a bit closer to Jupiter and you get to Io, the volcanic one.
Right, the hot mess of the solar system.
It's the most volcanically active body in the entire solar system, and we know why, which gets back to the physics Galileo was uncovering. It's because of something called tidal heating.
So Jupiter's gravity is just squeezing it.
Squeezing and stretching it constantly. That plus gravitational tugs from the other moons creates so much internal friction that its insides are basically molten rock. Hundreds of active volcanoes. It's a dramatic, violent place.
Then moving out, we get Europa, the icy mystery. This is the one that really captures the imagination today.
It does. It's smaller, and its surface is covered in these long cracks and reddish streaks. And those surface features are the clue.
The clue that there's an ocean underneath the ice.
Exactly. Researchers are almost certain there's a huge liquid water ocean under that ice shell, and the same tidal forces that melt Io's rock might be just gentle enough on Europa to keep its ocean warm. Maybe warm enough for life.
Which is why everyone wants to send a probe there. Okay, and the last one, Callisto, the ancient one.
Callisto is the fourth and farthest of the Galilean moons, and its story is one of history. It holds the record for being the most heavily cratered object in the solar system.
Meaning its surface is really, really old.
Billions of years old. It hasn't been resurfaced by volcanoes or tectonic activity. It's like a perfectly preserved photograph of the early solar system.
So you have these four completely distinct worlds, each a scientific treasure, and Galileo saw them dancing around Jupiter. This was his proof, the irrefutable evidence. But it came at a monumental cost.
It really did. The sources are very clear that he was persecuted for decades, not just for the observation, but for his passionate defense of the heliocentric, the sun-centered universe.
This wasn't a scientific debate. This was seen as an attack on the entire world order.
And it escalated. It went all the way to a formal trial in 1633. Galileo was tried by the Holy Inquisition.
Yeah, the verdict.
He was found vehemently suspect of heresy. Think about that. Not for a crime, but for being suspect of heresy, for challenging authority with something he saw with his own eyes. It was a direct clash between observation and dogma.
And the sentence was just isolating. He was forced to publicly recant, to say he was wrong, and then he was put under house arrest for the rest of his life.
Imagine that. Being confined to your home simply for proving a scientific fact.
The irony, though, is that even then, he didn't stop.
No, his dedication was incredible. While under house arrest, he wrote one of his most important works, Two New Sciences. It summarized 40 years of his work on motion and mechanics. He made sure the knowledge would outlive him.
So what does this all mean for us? I mean, today you learn in elementary school that the Earth orbits the sun. It's a given. But we have to remember the incredible upheaval it took to establish that simple fact. It took one person willing to trust his eyes over everything he'd ever been told.
And we've been focused on the science, but it's important to bring in another perspective that one of our sources offers. We have to report on this impartially.
Right. One of the articles we reviewed quotes the Bible, Genesis 1:1, "In the beginning, God created the heaven and the earth."
And it explains that from this viewpoint, creation, including where the earth is placed, is part of a deliberate divine plan, a plan that allows humanity to be here and exercise our agency.
So you can see the conflict. Galileo's discovery challenged a specific physical model of the universe.
But for those invested in that doctrine, challenging the physical model felt like you were challenging the divine plan itself. The plan where humanity was the entire point. It helps you understand the stakes as they saw them.
It's this stark contrast. A scientific framework built on what you can see and measure versus a belief system built on revealed truth. The key is to understand that the scientific finding didn't happen in a vacuum. It forced a massive crisis of faith and philosophy.
Which brings up a really good question for you, for anyone listening. When you look up at the night sky now, Knowing about Ganymede's magnetic field or the tidal forces melting Io's core, what impression do you get of the solar system and, your place in it? Does that knowledge change anything for you?
This whole deep dive into Galileo, for me, it shows the power of curiosity, of improving your tools, that telescope, and the massive consequences of challenging the status quo, even with proof. His patience, just watching those moons night after night, that's where modern astronomy was born.
It proves that sometimes what you see right in front of your face is more powerful truth than what you've been told for centuries.
And speaking of seeing, our source material has a great actionable tip for you. Just on a clear night, find a telescope or even just a good pair of binoculars and look at the moon. Reconnect with that sense of scale that Galileo first unlocked for all of us.
Let's leave you with this final thought to mull over.
Oh,
Galileo's greatest summary of his life's work, Two New Sciences, was written while he was forcibly isolated. Why? Because his observations contradicted what everyone accepted as knowledge. So if observation is the foundation of science, what critical observation might we be dismissing today? What are we refusing to see, simply because it challenges a comfortable, long-held view we just don't want to let go of?
Thank you for joining us for this day in his story. May the lessons of yesterday inspire you to see God's hand today and to play your part in his story now. For more faith-based learning, visit ahsworldwide.org, the homeschool for faith and family.